Alright, welcome back to Ellensburg Amplifier Repair and Service with part 2 of this ATG2400.1D, an Audio-To-Go amplifier. If you missed part 1, you will see a card right up here in the corner here pointing you to part 1 of this if you're interested in seeing the beginning of this adventure on this amplifier. So what you'll see here is I have all the parts laid out. I have our 15 volt voltage regulators that I'm going to be replacing. I do have the 3205s here for the power supply that I will be replacing. I have the rectifiers, the 1620 rectifiers that I will be replacing, and I do have 4 31N20Ds that I will be installing back into this board. I do question these. I always question all parts that have been discontinued or obsolete. So we'll see what the signal looks like when we get this put together and fired up. I will be replacing the rail capacitors, obviously. Looks like due to temperature probably, looks like they have failed, obviously. There's a hole in these. And I will be replacing these with new 63 volt 1000 microfarad capacitors. I will pull out these old components. We'll get the new ones in, and please stick around if you want to see the resulting signal on these transistors. I will be right back with you. Alright, I've returned. I've got all these components soldered back in place. It all went well. I'm just going to clean up a little bit of this extra flux that I have laying around here to help make the bottom side of this more presentable. And it's always a good idea anyways to keep your work surfaces clean that you've repaired. It just gives a good impression to future repair technicians that might get this in for another repair. It just shows good professionalism to keep everything clean. What I will do is just fast forward this real quick here and introduce a signal into this and see what our output looks like. Alright, let's flip this over. And as you can see, we do have the new 3205s installed, new voltage regulators, new rectifiers, and new output transistors. And what we'll do here is I will hook up my power supply. We'll get the oscilloscope fired up, and we will see what the outcome is. I'll be right back with you again. Alright, let's fire this up together for the first time here. So let me grab my channel 1 probe here. And let's see what we got here. So I've got my 12 volts there on my incoming power. Again, this is an isolated 2 amp power supply that I use. We got the foot switch here giving me my 12 volts on the remote. I do have a red light coming on telling me that the remote circuit is functional. So what I'm going to do is just pulse real quick the power supply drive here just to see what the signal is looking like. So I'm going to drop the scope down to 5 volts. So we'll get, sorry for my hands in front of the camera here. What we'll do is get the scope hooked up to the drive signal, hands free. Alright, so I'm just gonna get a good power supply. There we go. You'll see the drive building there. building up. So we do have the TL494 drive is active. So I'm just going to check the rail voltage, make sure my rail voltage is trying to build, and it sure is. So let's increase the scope voltage here. So we are getting up to about 36 volts, which, if I remember right from part 1 of the video, at the top of the card, if you missed the part 1. And I do believe we went through on the first part and the drive was still good, if memory serves me right. So the biggest thing is to make sure that we have our positive and negative 14 volts, positive negative 14 volts at our preamp. So far everything's looking good. We have our power supply drive, we have rails building plus and minus, or positive and negative rail voltage, if you would like to call it that. And so now we'll just check the output drive, make sure the output drive is switching. Which, there's our output drive. So I'm just gonna real quick just make sure I don't have any excessive heat going on here, which I do have a little bit of heat. So that's the negative drive, which we do have, but it gets way too hot. So we do have these transistors are probably what I would call fake, because they are getting way too hot. I don't have any shorts present. It's just the heat. It does go into thermal runaway. So I did question these transistors at the very beginning, which does really confirm to me that the values of these are off. Probably the RDS is off. So back to square one. Alright, so in this last section that I recorded, I did find that I did have some transistors that did not function as intended in the circuit. And this is where I kind of wish I had some form of microscope to show you guys how I kind of knew before I even put these in that these are fake. But when you look at the face of some of these transistors, if you look really close, you'll see what looks like to be sandpaper marks on the face of transistors or ICs that you purchase. These did not come from overseas, just to let you know. And you'll see these lines, and that is one of the first indications that these have been sanded off. And on the edges, you should have nice round corners on the transistors if they're original. And when you look real close under a microscope, you'll see this edge, which is just a sign that this has been sanded off, which I knew in the beginning, before I even put these in, that I questioned these because it does look like they were sanded off. So what I did is I replaced these four here with some 4227s, which have a little lower RDS. They kind of have the same ratings. Well, they're a close match, I should say, to the 31N20s. Just doing a quick search for equivalent parts, not direct replacement parts, but equivalent, which might work in the circuit that you're intending to use them in. So I was just waiting for these to cool down just a little bit from the iron. from the Hacko 808 that I use to solder into the bigger trace areas. So I'm just waiting for those to cool down just a little bit. I still have the scope fired up. The scope's still set. I don't have any shorts. Here, just a beat probably for capacitors. Nope, we're good. So that's the low side, and this is the high side. Excuse me, correction. And this is the rail-to-rail oscillation. So you have 2 for the rail-to-rail, and you have 2 for negative rail reference drive. So once those cool down, what I'll do is I will fire up the power supply again here, and we will see if these react the same or not. Hopefully these 4227s shouldn't heat up quite as significant as the fake 31N20Ds. I'll tell you what, that negative reference one, it got hot quick. I do have a thermal camera that I use for bigger amps, but these smaller amps here, I just kind of go by feel real quick, because if you have one that doesn't work right or is shorted, they heat up pretty quick, even at 36 volts on the rails. So what we'll do is we'll just fire this back up again. Just make sure I got my green light coming back on. Alright, so what I've done is replaced the 31N20Ds with 4 227s, as I had mentioned. So I just wanted to show you how I came about with using the 4 227s. So you'll see here on the screen that the 31N20D is rated at 31 amps, and the 4227 is rated at 65. I do believe that says. It's kind of small on my screen here, but you can see that's how I chose the 4227. I have 4 227s on hand, so that's what I used. It does have a lower RDS. It does have a higher amperage rating. Still 200 volt, so I figured it was a good match. It shouldn't run hot at all. So what I'm going to do is I'm just going to go ahead and run this for a second. As soon as I switch the screen for you, there we go. You'll see up by your left hand corner there at the top there, you'll see the switching activate for the output, and there it is. The output switching is there for you. The 4 227s are staying absolutely cool. Let me bring the voltage just a little bit here, and then the negative side switching. Let me bring that voltage up just a little bit here, and bring the trigger down to catch this. So it does have the negative side. It's definitely switching. These 4 227s are just getting slightly warm, nothing near as hot as it was getting before. Otherwise, it's looking pretty good. So what I'll do for this, just to test these 4 227s, is I will put it back in the heat sink, and I will put it on my load bench, and I will run these 4 227s. I will run the amp at full throttle and see just the thermal characteristics of the 4 227s and how it operates with the gate resistors that it has. I may have to do some changing on the gate resistors to compensate for the switching of the 4 227 difference between the 31N20Ds. So otherwise, I think this is good to at least go on a test bench and see what the resulting outcome is. I do have a new website up. It's called ellensburgamplifier.com, where you can actually purchase amplifiers at a highly discounted price. Otherwise I start to get a pile up on these amplifiers, and I like to get them back into vehicles. So please check it out, ellensburgamplifier.com. Please like and subscribe if you like amplifier repair content. I will see you soon again.